That means optimum design of transformer is totally depends on their losses and their cost, weight and volume. Okay. Then also in which we have to need their parameters. Okay. Then now first we have to calculate design for minimum cost. That means we have to calculate first cost of the transformer. Okay. Then in which we have to consider three-phase transformer. Okay. Always you have to consider single phase transformer. Depends on your choice. Okay. Then this is the EMF equation. Then we have to calculate voltage per turn equation. That means TT get cancelled. Okay. Then this is the equation for three-phase transformer EMF equation for voltage per turn. Okay. Then also we have to calculate total copper loss of the three-phase transformer. This concept already I have explained in unit number 2. Okay. Now we have select two windows, then TP into AP plus TS into AS. But the formula of AP is equal to IP upon sigma, AS is equal to IS upon sigma. Okay. That means in this design we have to calculate minimum cost of three-phase transformer. Okay. Then AC is equal to 2 into TP into IP upon sigma plus TS into AS upon sigma. Okay. Now this is the rearrange equation. Now in which we have to find out their minimum cost. Okay. Okay. Then AC is equal to, then put TP IP TS into IS is equal to 80. That is ampere turns. Okay. That means put TP into IP is 80 plus 80. That is 80 plus 80 twice 80, and 2 is multiplied by 2 is 480. That is AC is equal to 480 upon sigma. Okay. Now also in which we have to need to find out their minimum parameters which is required for to find out the minimum cost of the transformer. Okay. Then next formula is window space factor. That is KW is equal to AC upon AW. Then AC is equal to KW into AW. That is equation number 5 put in equation number 4. That is equation 4 becomes, that is AC is equal to 480 upon sigma. Okay. But the value of AC is there. Okay. This value put in this equation. Okay. That is KW into AW is equal to 480 upon sigma. That is we arrange equation for ampere turns. It is equal to KW into AW sigma upon 4. Then this is the output equation of three-phase transformer. Okay. Then also in this equation window space factor is, this parameter is very important. That is KW is equal to AC upon AW. Then rearrange equation for AC is equal to KW into AW is equal to AC. Okay. Now in equation number 7, that is put KW AW. That means put KW AW is equal to put AC. Okay. Then equation is Q is equal to 3.33 F into BM into sigma into AC into AI into 10 raised to minus 3. That means in output equation we have to put AC is equal to KW into AW. Okay. But in minimum cost, net iron area is depends on flux density, that is BM, and area of copper is depends on current density. That means AI, the value of net iron area, is depends on flux density, that is BM. Okay. Then the value of AC is depends on current density. Okay. That means these two parameters is very important. That means AI, that means net iron area, is depends on maximum flux density and current area of copper conductor is depends on sigma. That means AI and AC is depends on BM and C. Okay. Then also we have considered two parameters, that is AC and AI. That means we have considered constant value of AC and AI, because these two parameters is very important to find out minimum cost of the three-phase transformer. Okay. Then we have to put AI is equal to AC and AC is equal to AI. Okay, that means put AC into AI is equal to C. Okay, then C into C square. Okay, then also in which equation we have to need their optimum design. Okay, that means optimum design of transformer is very important. Okay. Then this is the optimum design. Basic formula is R is equal to phi m upon AT. Phi m means maximum flux and AT means ampere turns. Then rearrange equation for phi m. Phi m is equal to Bm into AI. Okay. Then also we have to need ampere turns. This is the formula for three-phase transformer ampere turns. And this value equation AT and phi m, both values put in equation number 10. That means phi m put here and AT. That means equation 11 and equation 12 put in equation number 10. Then R is equal to phi m upon AT. Then phi m is equal to rearrange equation for phi m is phi m upon AT. This phi m is equal to Bm into AI. This is the formula. Okay. That means the phi m is equal to Bm into AI. Put here. And ampere turns, that is AT. kW into AW sigma upon 4. Put here. That means both values are put here. Okay. Then 4 is get upper side, that is R is equal to 4 into Bm into AI upon kW AW sigma. But kW is equal to AC upon AW. That means during the space factor is the ratio of area of copper upon area of window. It is rearrange equation for AC here. AC is equal to kW AW. Then put here kW AW is put here AC. Okay. Then R is equal to 4 into Bm into AI upon AC into sigma. This is the equation number 30. Okay. Now also in which we have to need next parameter is okay. Then also in which we have to arrange equation for AI upon AC. That is next equation is R into sigma upon 4 into Bm is equal to AI upon AC. That means we have to arrange area of net iron area upon area of copper. That means this two value is very important for to design the parameters of transformer. Also this two parameter is very important to find out minimum cost of the transformer. Okay. Then AI upon AC is equal to 4 upon sigma upon 4 into Bm into R into nearly equal to Z. Okay. That means AI upon AC is equal to Z. That means this value is nearly equal to Z. That means this is a constant value and put here Z. Okay. Then AI upon AC is equal to Z. Then rearrange equation for AI. AI is equal to Z into AC. Equation number 4. But initially we have to consider put AC is equal to constant C and AI is equal to put constant C. Then C into C square. Okay. Then equation number 14. Equation number 14 put in equation number 15. That means this equation number 14 is put in equation number 15. Okay. Then AC into AI is equal to C square. But the value of AI is here. This value is put in this equation. Okay. Then AC into Z into AC into C square. Then Z into AC is equal to C square. Then Z is equal to AC square is equal to C square. Then AC square is equal to C square upon Z. This is the find out the value of AC. That means in minimum cost of the transformer, we have to find out first value, that is AC is equal to this value is very important. Then find out AI. AI is very important. Okay. Then both equation. In this equation, we have arranged equation for AC. And in this equation, we have to arrange equation for AI. That means this is the equation for AC. And this is the equation for AI. Okay. AI is equal to Z into AC. But rearrange equation for AC is equal to A upon Z, equation number 2. Then AC into AI is equal to C square, that is equation number 3. Okay, then put the values of AC here. Okay, that means AI upon Z into AI is equal to C square. Okay, then AI square is equal to Z into C square. That means these two value is very important for the find out the minimum cost of the transformer. Okay, then also in this equation we have to need their parameters. Okay, then also in this equation we have to calculate different parameters. Okay, this is the minimum cost of the transformer. It is depends on value of AC and AI. Okay, then these are the nomenclatures. That is CI, that means total cost of the iron. CC means total cost of the conductor, and CT means total cost of the transformer, that is active material. CT is equal to CI plus this, CI plus CC. Okay, then okay, these are the important parameters to find out the minimum cost. That is SCI means specific cost of the iron. Then SCC, that is specific cost of the conductor, rupees per kilogram. Then GI means weight of iron. Then GC means weight of conductor. GI means volume of iron. GC means volume of conductor. LI means mean length of iron in meter, and length LMT means mean length of turn in these symbols is very important to need to find out optimum design of transformer. Okay, then go to the next equation to find out total cost. Okay, then CT is equal to CI plus CC. SCI GI plus SCC into GC. SCI means specific cost of the iron, and SCC means specific cost of the conductor. Okay, and GI means weight of iron. GC means weight of conductor. Okay, then SCI is equal to GI into LI into AI plus, that means the formula of GI, that means this GI, value of GI, and GC, that means weight of iron and weight of conductor. This formula is there. These two values are put here. Okay, SCI is equal to GI into LI into AI plus SCC into GC into LMT into AC. That means these are the nomenclature. This is very important. Okay, now previous equation we have to find out two values, that is AI and AC. Okay, AI is equal to C into square root of Z, and AC is equal to C upon root Z. Both values are put here. Okay, then total cost is equal to SCI into GI LI into C square root of Z plus SCC into GC into LMT into C upon root Z. Okay, now equation number 19 is the minimum cost of the transformer. Okay, now we have to find out exact cost of the transformer. Now differentiating with respect to Z. Okay, now equation number is 19, differentiating CT, that means the CT with respect to Z. Okay, then dCT is equal to d upon dt, this equation as it is. Okay, now this constant parameter is taken as outside, this constant parameter taken as outside. Only this parameter is very important for daily. Okay, these are the name. Then constant parameter as it is, then C into Z into 1 by 2, that means we have remove square root, SCC into GC into LMT upon C upon the derivative is C is constant 1 upon root Z, that is C upon C root Z as it is taken as, but in this equation we have to consider derivative for Z, that is 1 by 2 as it is, that means n into x raised to n minus 1. This formula is used here. Then 1 by 2 is Ci into Gi into Li, C into Z raised to minus 1 by 2. Then also this formula is applicable for this equation, that is minus 1 by 2 SCC into GC into LMT C into Z raised to minus 3 by 2. That means Z is C raised to 1 by 2 taken as. Then this term is go upper side, that is 1 minus 1 by 2. It is 2 minus 1 by 2 is minus 1 by 2 as it is, and plus minus 1 by 2 plus 1, that is we arrange minus 3 by 2 with respect to minus 1 by 2. Okay, that means this derivative is very important. Okay, then also in this equation, this right hand side and this is left hand side. Okay, then rearrange for left hand side is equal to right hand side, and then put derivative is equal to 0. Then this is minus term, get shift right hand side, that is equation as it is. Okay, then 1 by 2 get cancel, remaining term as it is. Okay, then also in which we have to need rearrange equation. Okay, then SCI into GI into LIC Z raised to minus 1 by 2 SCC into GC into LMT CZ raised to minus 3 by 2. Okay, then this value as it is taken C by Z and C by Z into minus 1 by 2. This solution is getting here. Okay, that means C of Z raised to minus 3 by 2, C of Z minus 1 by 2. So then this term get negative, goes to the upper is positive, it is minus 2 by 2. Then C into Z raised to minus 1 by minus 1, that is C is equal to 1 by Z. Okay, that means Z inverse is 1 upon Z, and CC get cancelled. CC get here cancelled. This is not taken here. This Z is equal to 1 by Z. Z inverse converted into 1 by Z. Okay, then also in this equation we obtain SCI into GI into LI is equal to SCC into GC into LMT into 1 by Z. Okay, but initially we have to find out the concept is AI upon AC is equal to sigma upon 4 into BM. R is nearly equal to Z. But also in this equation we have to rearrange equation for AI upon AC is equal to Z, and also in which we have to need to find out the values of AI and AC. Okay, also in this equation also need to find out their optimum design. Okay, then optimum design of transformer is very important. Okay, then in this equation AI upon AC is equal to Z. Okay, and also next equation is SCI into GI into LI is equal to SCC into GC into LMT into AC upon AI. Then the value of AC is move left hand side. Okay, that is SCI into GI into LI into AI is equal to SCC into GC LMT into AC. Then this is the value of SCI and GI. This is the value of SCC and GC. That means this put here and this put here. That means ह्या दोन ज्या व्हॅल्यू आहेत त्या SCI आणि GI च्या आहेत, ह्या दोन व्हॅल्यू, and ह्या दोन व्हॅल्यू SCC into GC. That means both are equal to each other. Okay, then CI is equal to CC. That means CI is equal to SCI into GI. That means initial formula, and CC is SCC into GC. That means in this equation minimum cost of the iron, that means minimum cost of the iron is equal to minimum cost of the conductor is very important. That means both values are equal to each other. That means minimum cost of the iron is equal to minimum cost of the transformer. Then we have considered small transformer, that is minimum volume of the transformer, that is in which we have played volume of iron and volume of conductor is very important. Then minimum weight of the transformer, that is weight of ion and weight of conductor is very important. Okay. Now this is the minimum cost of the transformer for three-phase transformer. That means weight of ion is equal to weight of conductor, and minimum cost of the ion is equal to minimum cost of the conductor. Okay, now this is the first parameter, that is cost of the transformer. Then we have to find out minimum loss. First find out minimum cost, then second parameter is minimum loss. In minimum loss of the transformer, minimum loss means maximum efficiency. That means there is no losses. Okay. Then PI is called as total iron loss of the transformer. PC means total copper loss of the transformer. That is PC is equal to I square R. This is the important formula. Then total losses of transformer at full load is PI plus PC. Now consider load is X. Then total losses are PI plus PC. Then put the values of PC is depends on resistance, that in which the total losses of resistance is depends on inductance of the transformer. That is PI plus the value of losses is PC is equal to X square. We have considered leakage reactance, that is X. Here consider leakage resistance, that means resistance of transformer. But in this equation we have to find out with respect to copper loss is leakage reactance, that is loss is equal to PI plus X square DC. Then Q is output at full load, and output at X load is X. That means we have considered Q means output of the transformer with respect to full load, and load is considered X, that is X into Q. That means the output of the transformer is depends on load, that is Q into X. But efficiency of the transformer is very important. This is the efficiency formula, that is N is equal to output upon output plus losses. Now this is the output, that is put here X into Q, output here X into Q, plus losses is PI plus X square into PC. That means these three values are put here, that means losses and output. It is output upon output plus losses. All three values are put here and find out minimum losses, that is maximum efficiency of the transformer. Okay. Then also in which we have to find out minimum losses of the transformer. Okay. Then next equation is minimum losses of transformer. Okay. Then Nx is equal to X into Q upon X into Q plus PI plus X square PC. Then we are using mathematical formula, that is U upon U, that is V du upon dx minus U into du upon dx. This value is U and U. Then this is the formula rearranged for this equation. Okay. Then we have taken the derivative, that is V upon U. Okay. That means V as it is into du upon dx. We have taken any value. Okay. Now we have considered value of phi. This is the value of phi. Put here derivative of u, that is x into q. Put here. Then x u as it is here, and derivative of the v here. Put here. Okay. And upon square of v square. I think we have not written here v square. Okay. Then v square. Okay. Then put derivative with respect to x. Then taken the derivative of x is 1 here and q as it is. Okay. Then take the derivative of x. X is 1, q as it is, and plus the value of pi is not consist of x. Then taken derivative is 0. Then x square twice x plus pc. Okay. Then put derivative is equal to 0. That means this value get put here 0. Then this ratio is directly cancelled here. Then next equation is x into q plus pi plus x square into pc into q minus x into q Q plus twice X. Then multiplied by Q. X into Q square plus Pi into Q plus X square into Pc into Q. Then multiply. This equation is under here. Okay, that is X into Q square plus twice X square into Q Pc. Okay. Then this value get cancel. This value move right hand side. This Pi into Q is equal to Q into X square into Q Pc minus X square into Pc into Q. Okay. Then obtain value is Pi into Q is equal to X square into Q into Pc. Then Q get cancel. Pi is equal to X square into Pc. Okay. Now this is the minimum loss. Then also in which find out. Okay, that means Pi is equal to X square into Pc. Now this is the thus transformer gives maximum efficiency with respect to constant losses. That means minimum losses it gives maximum efficiency. Okay, now this is the minimum losses of the transformer. It depends on output and load.